After understanding how JavaScript assigns values to variables, whether it's primitive, non-primitive values, whether it's a copy of the value or a reference to the same object, we can apply this knowledge to functions and functions parameter. So in JavaScript, when we define a function, we also can define parameters. And when we call a function, we pass a value to this parameter in the function. In the case here down below, we're calling the function do something and we pass the variable a to the function do something. Now, the way the JavaScript handles the values and the variables behind the scenes when it comes to parameters is the same as handling regular values. So just like saying declaring a variable a and assigning b to equal a. This is what we're doing here. We're assigning b, the parameter b, to be equal to a when we call do something with a. Now this can cause a side effect. What is a side effect? I have a function here that accepts two parameters, text and object. Inside here I'm mutating text. Now you can see that text will be a string, so I'm mutating something which is non-primitive. In the case of object, it's a non-primitive value and I'm mutating a property inside of it. Down here I'm creating two new variables, a equals hello, which is a string, and b equals this object with a property width of 400. And I'm calling do something and passing down a and b. Now if you'll go up, you see that a will be assigned to text and b will be assigned to obj. And you can think of it behind the scenes just like saying text equals a and obj equals b. So the same rules, whether it's non-primitive or primitive value, applies to those parameters. Because JavaScript received a string here, it creates a copy. So text is pointing to a copy of hello in the memory. It's not the same place in the memory, it's a copy. So when I'm changing text, I'm saying text equals something else, I'm not changing the string that a is pointing to. But when it comes to object.width equals 550, passing b to do something and object equals to b. Now b and object are pointing to the same object in the memory, even though it's inside the function. So when I'm assigning a new value to width, a property of the object, I'm changing the same object that b is pointing to. So if you'll see here when I console log a, it stays hello, it doesn't change, even though I changed text here, because text received a copy, but when I console log b, b changes. So the object that p is pointing to changes because I have the same object inside the function and I'm changing this function. This is called a side effect because I'm changing something that lives outside the function. You see, b lives outside the function. It's the same object in the memory, and I'm changing this object inside the function. I'm creating a side effect because I'm also changing something that lives outside the function. And usually this is something we want to avoid. It can cause some weird bugs. We can see that now b changes, but it might not be my intention. I don't want to change something that lives outside of the function, and then I don't understand why it's happening. Something cool here, if I'll open the inspect tab here, let's create a new object. So width, it's 400, and I'll do function, and I will do object dot width equals 550. Okay, and let's console log b here, and you can see that object is width 400. Now let's go do something with b and console log b here. It says width 400. You can see now that the width is 550 in the previous console log. This is because it's the same object in the memory, and when I'm console logging an object in the console inside the browser, it takes a reference to the same object. So if I'm changing it, when I will expand it, it will give me the new value or the updated value. So now we see the updated value of the same object. How can we avoid side effects in functions? What we want to do is to deep clone objects. Now this is the first solution, although it's not a recommended one, but I want to present you this solution because this was used before the new solution came into JavaScript. So one thing we can do is we can stringify object, right? We're receiving an object inside the function, we're stringifying, we're creating a string that represents the object. Why creating a string? Because string is a primitive value. So it will create a new copy of the string in the memory instead of having a reference. And then we're parsing, we're just telling JavaScript, take this new string and create a new object out of the string. The string has the shape of an object, and parsing will create a new object out of it. Therefore, we're creating an object copy. So when I'm changing object copy, I won't change B. There will be no side effect because I created a copy inside the function. Nowadays, in JavaScript, we have something called structured clone. This is a function that is available to us in the global scope. We don't need to import anything. It accepts an object and it just creates a deep copy of the object for us. Clone does just what we're trying to achieve. It creates a copy of the object, so it won't have a reference to the same object, so we can change it without causing a side effect. So typeof is an operator in JavaScript that gives you the value of the variable. So if you remember, next to the values, I also wrote the type of the value next to the memory. So A is pointing to an object, and this is the type of the object. Or C is pointing to a string, and this is the type of the value, it's a string. And we can use, thanks to the typeof operator, to ask JavaScript what is the type of the object, or what is the type of the value that the variable is pointing to. So if we create a new string, and we will ask JavaScript what is the type of the value that string is pointing to, it will give me a string, and it will include the type of the value that A is pointing to. So if const B is equal some object, I'll create an empty object, const C, I already have B declared, and I will do type of B, it will give me object, okay? So I can ask, let's see, type of A equals object, false, because A is a string. But if I will do string here, it will give me true. This can be handy if you want to check what is the type of the parameter or any variable in our code. It can return undefined, number, string, object, null, begin, symbol, and function. Now something weird, type of null equals object. There is a reason to it. I will post the reason in the comments. And also type of none equals a number, which is weird. None stands for not a number. So why not a number is a type of number? Not sure, but this is how JavaScript works.